everybody, my name is Peter Klapper from the School of Biosciences at the University of Kent in Canterbury, and in this video clip I want to discuss with you the concept of competitive reversible inhibitors. Now, why is this such an important concept in enzymology? Well, the answer is these kind of inhibitors are extremely important when it comes to the pharmaceutical industry. Basically, all the pharmaceutical industry approaches are based on competitive inhibitors which they develop to reversibly inhibit specific enzymes. So how does it work now? To understand competitive inhibitors, it is important to bear in mind that the competitive inhibitor can only interact with a free enzyme. And that is, in general, the definition of a competitive inhibitor. So, what's going on here? Let's write down our scheme for a Michaelis-Menten enzyme. So we have enzyme plus substrate, and usually this is in a reversible reaction. We get enzyme substrate complex, and this then dissociates into enzyme plus product, and obviously the enzyme then can start a new catalytic cycle. Now, a competitive inhibitor can only interact with the free enzyme, with this guy here. So we can write it inhibitor plus enzyme, and this is a reversible reaction. Mainly reversible reactions are interesting. Irreversible reactions, irreversible inhibitors also can be of high interest, but we are not going to discuss that here. So what happens if the enzyme and the inhibitor interact with each other? Well, they form an enzyme inhibitor complex, but this enzyme inhibitor complex can't do anything with the substrate. So basically the inhibitor takes away free enzyme, and what we see is that either the inhibitor binds to the enzyme or the substrate binds to this enzyme. But they can't bind at the same time. And that is very important to understand the mechanism of such an inhibitor. So how are they going to do that? With competitive inhibitors, we can distinguish two ways of action. Now, the first and the most common one is that the inhibitor binds to the active site. Let me illustrate that to you. So imagine I'm an enzyme and my active site is here. And here is a substrate. And you can see through induced fit, the substrate would bind quite nicely to the active site. And I can do something if I didn't drop my substrate. Okay, so substrate binds to the active site. Now here I have an inhibitor. It looks fairly similar to the substrate, but it's not exactly the same. Now what it can do is it can bind also to the active site because it looks very similar to the substrate. So like that. But what you see is that it can only be either the substrate or the inhibitor that can bind. So if the inhibitor has bound, the substrate can't bind. Or if the substrate has bound, the inhibitor can't bind. So they are mutually exclusive by binding to the active site. Now, the second option in which a competitive inhibitor can work is that it binds to a different site, and different site or other site in Greek means allosteric. So this would be an allosteric inhibitor. So what's going on? Again, we have the substrate, we have the active site. The substrate can bind to the active site. Now here comes an inhibitor. This inhibitor, you will agree with me, this looks very different to the substrate, but this inhibitor can bind to the active site like that. So here that would be the allosteric site where the inhibitor binds to, like that. And because this inhibitor induces a conformational change in the protein, and obviously this book is quite heavy, I can't open the active site wide enough. So again, the inhibitor stops the substrate from binding, but not because it binds to the active site, simply because it prevents the substrate from entering the active site through the conformational change. And again, it's either the inhibitor can bind, but then the substrate can bind, or the substrate can bind, the inhibitor can no longer bind. So both substrate and inhibitor are mutually exclusive in both cases. So let me spell this out again to make it absolutely clear. With a competitive inhibitor, it is very important to recognize that the competitive inhibitor and the substrate are mutually exclusive. So if the inhibitor has bound, the substrate can't bind, and if the substrate has bound, the inhibitor cannot bind. And that is the essence of a competitive inhibitor. And it really doesn't matter whether the inhibitor binds to the active site or whether it is an allosteric inhibitor. The effect is the same. Either the substrate binds, then the inhibitor can't bind, or the inhibitor binds, then the substrate can't bind. I hope this makes sense, and in the next video we will explore the properties of such a competitive inhibitor. Thank you very much for watching, and see you soon.